Next, we will hear from DARPA Microsystems Technology Office Program Manager, Mr. Keith Rebello.
Today I'd like to talk to you about the future of secure systems. Computer systems today, this is embarrassing. What's worse than doing security updates in the middle of your presentation? How about losing power to your computer? Or worse yet, power to the building, or even a city. Cyber attacks are here and only growing. It's estimated that by 2021, they'll total $6 trillion in damages annually. They're very widespread. Just recently, we heard about Garmin and how it was a victim of a ransomware attack that knocked its computer systems off of the internet for 4 days. Ransomware attacks are only increasing. Thousands of them are occurring every day. It's a big problem. I'd like to talk with you briefly about some of the performance and security trends that we're tracking here at DARPA. We've been a beneficiary of advances in Moore's Law when it comes to our computers, but as of late, performance has tapered off, and we can see this in our desktop systems and laptop systems. Unfortunately, when we look at vulnerabilities, they've only been increasing. And you can see from the trend lines on this plot, it looks very troubling. We're increasing at an exponential rate. Well, how do we deal with these security vulnerabilities and cyber attacks? Well, what I've shown here on the left is a computer system stack consisting of software, firmware, and hardware. These cyber attacks are software programs that attack the system. Many of these attacks attack the underlying hardware itself. How do we deal with these? Well, we deal with them with patches. We put patches on our software programs, on new versions of software programs, and oftentimes it's like being in a hamster wheel. We're racing to keep one step ahead from our adversaries. Not only is this a security risk, but we also take a performance hit from all of the monitoring that's done. It's said that in Microsoft Windows, it's about 20% due to software patches. Our vision for the future is better hardware. Hardware that is able to detect and prevent these types of attacks that will obviate the need for software patches. And that's really what SITH is all about. Our system security integrated through hardware and firmware program has shown that it is possible to close entire classes of cyber vulnerabilities. Let's take one just for an example, the first one, buffer errors. So memory attacks and buffer overflow attacks, these are a big deal. They make up 70% of all cyber attacks. And we've shown that we're able to close these with our new architectures. But not only that, we've been developing enhanced security benchmarking tools. Right now, there's no agreed upon standards for security benchmarking. And we've developed a software tool that enables us to quantitatively measure the security performance of our computer systems. You may have heard about PhET, our Finding Exploits to Thwart Tampering bug bounty. It's DARPA's very first bug bounty program where we're using a global community of white hat hackers to red team and penetration test the SITH hardware and also validate the SITH security benchmarking tools. We started in July and will be running for 3 months. And I'm happy to report as of today, no one has successfully penetrated our SITH defenses. I encourage you to find out more about what we're doing at phet.darpa.mil. Since SITH is working, we're very focused on transition. SITH has been incorporated into a number of commercial ASIC designs. The United Kingdom government has been funding high-performance ARM silicon development that is utilizing our SITH technologies, and we ourselves at DARPA are planning to create our own SITH ASICs that are tailored for DoD applications.